If I gave you a problem like this, I said, can you tell me to the power of 5? I can hear the scratching. That's what they complain about. Sounds like you're writing on chalk. I mean, your fingers on. Let me try this and see if that's different. Oh yeah, that's more. I'll take both. Let's see you want to do that. A plus b to the power of 5. Well, right now the only way to do it is what? It's a plus b times what? A plus b times a plus b times a plus b. Good luck. Times a plus b. I'll be back next week, see if you got it right. So it does take a while to get the answer to that. Is there another method we can use that will give us that answer without having to go through all that? And the answer, yes, we do have a method. Actually, we have two methods. One of them is called the binomial method. And I'll put that up there. It says if you want to find a plus b to the power of n, any power here, it's a to the n, the first one, or, oh well, second one is going to be n times a to the n minus 1 times b. That's b to the 1. And the next one should be n times n minus 1 over the 2 factorial. I'll explain what that is in a minute. A to the power of n minus 2, b to the 2. The next one is going to be n times n minus 1 times n minus 2 divided by 3 factorial times a to the n minus 3 b to the 3 plus blah blah blah, all that stuff. There's no way I'm going to use that method, but I'll go through one example with it, and I'll show you a different method. First, before I explain that method, let's talk about the factorial that you saw there. That's called factorial. So what's the factorial? So that's this exclamation point. If I write what's 2 factorial, that means 2 times 1, which is what? 2. 3 factorial. That's 3 times 2 times 1. What's 3 times 2 times 1? 6. 4 factorial. That's 4 times 3 times 2 times 1. You got the idea? 24. So you start with the number, and each time you decrease 1 from it, and you multiply them out. 1 factorial is 1. By definition, 0 factorial is also 1. Again, I'll never use this method, but I'll do one example with it. To me, that's too much work. So I want to do a plus b to the power of 5. So my n here is what? When you compare it to this one? 5. So this one says your answer should be, the first term should be this one raised to the power of 5. Now the next term says take n, which is 5, a to the power of what? 5 minus 1, that's a 4, times b. Plus the next one, 5 times, what's 5 minus 1? 4 divided by 2 factorial, a to the power of 3, b to the power of 2. The next one, it's 5 times 4 times 3, and minus 2 is 3, over 3 factorial, times a to the power 5 minus 3, which is 2, b cubed. Keep on going. The next one is 5 times 4 times 3 times 2 over factorial, a to the 1, b to the 4th. And the last one, because a will be to the 0, that's gone, it's 5 times 4 times 3 times 2 times 1 over 4 factorial. Notice each time I start with a to the 5th, each time I decrease 1 from the power for a, and I increase the power of b by 1. So when you decrease the power by 1 here, there's no more a. What's left is b to the 5th.
But it would still be 4 factorial down on the bottom?
5. I'm sorry, 5 factorial.
Okay.
Each time you increase by 1. Good eyes, Jennifer. So now if I do my math here, it's going to, so a plus b to the power of 5, it's going to be a to the 5th plus 5 a to the 4th b plus, what's 5 times 4?
20.
And 2 factorial, I have it written down as what? 2. What's 20 divided by 2? 10. A cubed b squared. Plus 3 factorial is 6. I have it written here on the top. So what's 5 times 4 times 3? 5 times 4? 20 times 3? 60 divided by 6? 10. Plus the next one, 5 times 4, 20 times 3, 60 times 2, 120. 4 factorial is 24. What's 120 divided by 24? That's 5 a b to the 4th. 5 factorial happens to be what? 120. So this will be a 1 here, and that's b to the 5th. As I said, this will be the first and last time you see me do the problem this way, because there's no way I'm going to remember these. So then how am I going to do them? I'm going to use Pascal triangle. It works fine, but I don't want to be doing all these factorial and doing all the crazy stuff there. So this method is known as Pascal triangle. That's what everyone uses. Remember it? It looks like a Christmas tree. It's perfect timing. It's almost Christmas. You start with these 3 ones. That's it. 1 in the middle, 2 under it. A little bit to the side. What's 1 plus 1? 2 put in the middle, 1's on the outside. Always try to spread them. What's 1 and 2? 3. What's 2 and 1? 3. 1's on the outside. What's 1 and 3?
4,
3 and 3.
6,
3 and 1.
4,
1's on the outside. 1 and 4. 4 and 6. 6 and 4. 4 and 1. 1's on the outside. And you can see the pattern continues. 1 and 5, I'll do one more. 6, 15, 20, 15, 6, and 1. And it doesn't end. You can go all the way to infinity. We use the top row here when the power n equals to 0, because anything to the 0 power is always what? 1. We use this when n equals to 1. This row when n equals to 2. This one when n equals to 3. This one n equals to 4. This one n equals to 5. This one n equals to 6. And so forth. Again, there's no end to it. Now let's go back to that problem we wanted to do. A plus b to the power of 5, right? What is that equal to? I'm going to begin by taking these numbers. The 1, 5, 10, 10, 5, 1. You see them for n equals 5? These numbers. 1, 5, leave a space, 10, 10, 5, and 1. Now, start with A. Start with A raised to the power of n, which is 5, and b to the 0. And after that, it's always a plus. After that, each time, reduce the power of A by 1, increase the power of B by 1. That'd be A to what now? 4, b to the 1. A to what? 3, b squared. A to the power of what? 2, b cubed. A to the power 1, b to the 4. A to the power of 0, b to the 5. Let's clean that answer. What's b to the 0?
1.
1. 1 times 1 is 1. You don't need the 1. A to the 5th. 5. A to the 4th b. 10. A cubed b squared. 10. A squared b cubed. 5. A b to the 4th. And what's this? B to the 5th. Was that the answer when we did it the other way? Look at the two answers. Yep. Now the problem, people said, what do I do if that was really a minus here? So let's try another example. And let's say it's not just A. I'll make it, let's have fun. I'm having too much fun here. Let's say I have 2x plus 3 to the power 3. I want to do that. So I find where n equals 3. I see my numbers. What are they? 1, 3, 3, 1. Start with the first one. That's the 2x. To what power? 3 times 3 to what power? 0. This one raised to that power, this one raised to 0. After that, decrease the power from the first one by 1 and increase the power of that by 1. Next one is what? 2x to the power of 1. You don't have to put the 1, right? 3 squared. You want to put the 1, go ahead. And the last one is what? 2x to the power of 0, which is a 1, times 3 cubed. What is 3 to the 0? 1. Okay, I don't need it. What is 2 cubed?
2 cubed is 8.
8. That would be 8x to the third, the first one. Two squared is what? 4. 4 times 3 times 3. 4 times 9, 36 x squared. Three squared is 9. 9 times 2 is what? 18. 18 times 3,
48.
54. And the last one is 3 cubed, which is what? About 27. Yep. 2 lines. What about if you have a minus there? I'll do another one. 3x minus 2y to the power of 4. You can't really use it for the minus. It has to be a plus there. So what I can do is rewrite that as 3x plus and negative 2y to the power of 4. This is A, that's B. When the power is 4, my numbers are what? 1, 4, 6, 4, 1. 1, 4, 6, 4, and 1. Start with 3x to the power of 4, negative 2y to the power of 0. The first one raised to all that power, the second one to nothing. Decrease 1, increase 1. 3x to the power of 3, negative 2y to the power of 1. 3x to the power of 2, negative 2y to what power? 2. 3x to the power of 1, I'm sorry, not 0, 1, negative 2y to the power of 3. 3x to the power of 0, negative 2y to the power of 4. In this case, it might be to your advantage if we take this and slowly go through the numbers to see what they answer to each one. Three to the fourth is what? That's the 1 here. 3 to the fourth, 3 times 3 is 9, 9 times 9, 81, x to the fourth. What's negative 2y to the power of 0? 1. Four times. What's 3 cubed? 27 x cubed. Times what? Negative 2y. What's 3x when you square it? 9x squared. And this one what? Is it 4y squared? 3x to the 1 is 3x. Negative 2 cubed is negative 8y cubed. 1 times 1 times what? Is that 16? Y to the 4th. Now let's multiply the numbers. 1 times 81. 81x to the 4th. This will be a minus because that's a minus. Let's see what that number. 27 times 4 times a negative 2. Negative 216 x cubed y. This will be a plus. 6 times 9 times 4. Plus 216. X squared y squared. Next one is a minus. 4 times 3 times 8. Negative 96. What do we have? X y cubed. And what's the last one? 16 y to the 4th. Worst case took 3 lines. There is no way I'm going to use the binomial method with a factorial and this and that. I always go to Pascal triangle. Every single time.
How would they ask that question on?
Simplify. Simplify 2x plus 3 cubed.
Is there any way to figure that out on the calculator?
Good luck.
Is that yes, or you just not?
I don't know how. Yep, I don't know how. But if you figure it out, let me know. I'm sure like computer software will do that, like Mathematica, you know, but it won't be on a calculator. That program is like $1,200 for a Mathematica for a license for one person. Yeah. We use that here.